Hey everyone, this week I'm going to be doing a little video talking about something that's important for the project and it's been happening around Earth orbit for almost 60 years now, but has not yet happened around Mars, and that's going to be docking. This is an important part of your project because you're going to need to have some kind of mechanism both when you first arrive at Mars and when you get back to Mars from visiting Phobos and Deimos, and that's going to be the docking of the two craft. Start with a little bit of background. The first ever docking between two spacecraft happened on Gemini 8 in the mid 60s. And that's pictured on the left happening where the Agena target vehicle was docked with the Gemini vehicle on orbit, all manually done by the astronauts. And this has gone a little bit further since then. In the mid 70s, the first international docking between two manned spacecraft occurred when Apollo spacecraft that was left over from the Apollo program and a Russian Soyuz spacecraft were docked. And developing the common compatible docking adapter is something that was a lot of negotiations and a lot of engineering had to occur between the Soviet Union and America. Something that was dramatized in the TV show the last couple of years, For All Mankind, on Apple TV. A little bit more recently, that collaboration kept up when in the 1990s, the largest space station, the only space station going on, was the Russian Mir space station. And part of a collaboration with the Americans at NASA, a docking adapter was developed to be able to allow the space shuttle to dock with Mir throughout the 90s. Nowadays, when things dock with the International Space Station, it's via two methods. One is berthing. We'll talk about berthing a little bit. It's shown here on the left with an old cargo spacecraft from SpaceX. Cargo Dragons, back then, they don't anymore, as well as a number of other spacecraft that are there to deliver supplies and are not manned, would dock via this berthing mechanism, where they would get near enough to the space station that the Canada arm, big robotic arm that sticks out of the space station, which is operated by someone on the space station, can reach out and grab it and bring it up to the docking port. This is used in a lot of cases to just add an added layer of safety to make sure that without people on board the spacecraft be able to stop it from running into the space station, it's important to constantly have it at arm's length, literally, make sure nothing hits anything. Nowadays, though, for the Crew Dragon spacecraft, the future Boeing Starliner spacecraft, as well as the Cargo Dragon spacecraft, pretty much anything not Russian, there is International Docking System Standard. And this is freely available. You can find this as well as the dimensions, specifications for copying into CAD and using in your own project if you'd like. And one specific docking adapter made based off of this is the NASA docking system, which is used on Starliner and on the current Cargo and Crew Dragon vehicles. The way this operates is there's a passive side and an active side. In this case, it's kind of flipped, this demonstration. This is the best GIF I could find, where in most cases, the active one would be the one moving because it's on the spacecraft, and the passive one is on the space station. But in this case, the active one is the top here, the darker metal one with just the three pedals that isn't moving. The way this works, going back, you see that there are three pedals in a triangular configuration. What happens is on approach, an initial soft capture is made when the three pedals on the one side reach beyond the three pedals on the passive side. What happens then is those latches on the silver, I see my mouse on here. These latches on the silver part right here latch on with their side on the passive side, and actuators on three arms connecting the active side to its spacecraft yank it in from the opposite side. And once in all the way, a series of hooks all around the circumference of the docking system will latch onto one another, kind of like this. And they'll go like that. And that ensures that the hard docking phase is complete. And the tunnel between the two, tunnel sticking off the edge of the space station, would then be pressurized, the pressures would equal, and the astronauts or the cargo would be able to go back and forth between the two. And showing an actual demonstration from a Crew Dragon mission this past year. See the active side approaching. When soft docking occurs, you see how it moves up on the screen. That's because the passive side is fully able to articulate in all three axes to cancel out any little bit of difference the spacecraft has in relative to the docking port. Not in the axis out of its nose, but in the other two axes. Cancels out that motion, and then hard docking occurs, and pressurization can occur through that tunnel seen on the right. Hope this helps with your projects. And once again, if you need anything, I'll be in my office hours Thursday afternoon. And if you need anything else, my email is on the page. Just let me know. Take care.